All right, everybody, welcome back to part 3 of section 1.1. We're going to focus in today on rates of change. And we're actually going to take some concepts we've already learned and just put some different vocabulary on these concepts, on these definitions. All right, so we're going to kick things off looking at when a function is increasing versus decreasing, which we've already done. But now we're going to talk about what it means for that function's rate of change. So a function's rate of change is going to be positive if that function is increasing. The function itself may or may not be positive above the x-axis, but its rate of change will be positive. So let's think about a graph real quick of an increasing function. So I'm going to draw a few of them. Let's say that this is our function. It's going up and to the right, it's increasing. Or this is our function, up and to the right. Or this is our function, maybe it's linear, up and to the right. All right, so all that means to say that the rate of change is positive is that if we took any 2 points on a graph, it doesn't matter which one, as long as on that interval the function's increasing, and we connected those points with a straight line, the slope of that line, I kind of missed the point a little bit, but the slope of that line is positive. It's going up and to the right. All right, so again, a function is increasing when its rate of change is positive. Likewise, a function is decreasing when that function's rate of change is negative. And again, the graph might be above or below the x-axis, but its rate of change is negative when the function's decreasing. All right, so again, decreasing looks like this, down and to the right, or down and to the right, or even down and to the right like that. All right, so now we're going to look at a function's rate of change when that function is either concave up or concave down. And so a definition of concave up is that the rate of change is increasing, and the rate of change is decreasing if the function's concave down. Now, the reason this gets confusing is we just used the words increasing and decreasing. They were talking about the function, not the function's rate of change. So if we take a graph that's concave up like this one, what is this saying? Well, it's saying that the slope of the function is getting bigger as we move to the right. So if I took 2 points that are close together, so I might take like this point right here, and a second point kind of close. I'm going to put it right about there. I'm just going to draw an X for those 2 points. So if I were to draw a line straight through those points, it's a very steep negative slope. But if I go a little bit to the right, like if I take that second X and I connect it to that third X, right there, the slope is less steep, it's less negative. And as we move to the right, it actually becomes positive. So the slope is getting bigger. Right, if I connected the third and the fourth X, the slope is about 0. And then after that, the slope is positive, whatever 2 points I connect. As we're moving to the right, the slope is getting bigger. And then if it's concave down, it's the other way. Right? The slope is decreasing. It's getting smaller. It's getting more negative as it moves from left to right. All right, so I pulled up a graph here from Desmos with some of the key points of that graph highlighted. And I want us to answer 2 questions. The first is about the actual function. So this is more based on part 2 of this lesson, when the function's A increasing, A positive, B increasing, and C concave up. But then the second question is about the rate of change of the function. All right, so let's zoom in a little bit on this function right down here. And so it's got some of the key points that are highlighted. It's got the zeros, it's got the 3 turning points, and it's got the y-intercept. It does not give us the points where it changes concavity. So we're just going to approximate those, and you will not need to find those in AP Precalc. That's more of a calculus standard where we look for what's called a point of inflection, where the graph changes concavity from concave up to concave down, or vice versa. But part A is asking about first, when is the function positive? So the function is positive when it's above the x-axis. So that's going to be starting at the leftmost 0. I'm just going to go to 1 decimal place. In this course, though, we are expected to go to at least 3 on any assessment that we have, 3 decimal places or more. But I'm going to go to 1 decimal place. So I'm going to start at negative 1.3. And the graph is going to stop being positive at about 2.2. Part B, when is the function increasing? So again, it's got to be moving up and to the right to be increasing. It's not asking about its rate of change yet, just the function. So we're looking for moving up and to the right. And so as we go from left to right, the graph is moving up in the first interval, so that would be from negative infinity to that relative maximum at about negative 0.6. That's the first interval. The second interval that it's increasing is this section, right? Made it white, so I don't know if it's easy to see or not, but that section right there from about 0.6 to about 1.4. All right, so 0.6 to 1.4. Now, concave up, it doesn't give us the actual points. That point at 0.8 is the y-intercept. But it also looks like that is very close, at least, to where that function switches from opening down to opening up. And so most of this graph is concave down, but there's a little section in the middle where the graph is concave up. And so that's going to start at x equals 0. And again, it doesn't give us the point. I'm going to approximate that. It looks like that point right there is roughly at 1, where it stops being concave up. There's that little section in the middle of the graph where it's opening up. And so it's about from x equals 0 to x equals 1. All right, so again, all those questions were based on our ideas from yesterday's lesson, or from part 2 of this lesson. Part 3 now, we're looking at the rate of change of this graph. So it says find when the rate of change of f is positive, and then find when the rate of change is increasing. So a positive rate of change, all that means is that the function would be increasing. So we can actually take our answer from part B here, and we can just move it, and it's the same answer right there. Part B is asking about when the rate of change is increasing, not the graph. The rate of change is increasing. Well, that's the definition of concave up. And so we can take on, or from part A, or part 1, we can take our answer for concave up and just put it right there for when the rate of change is increasing. All right, that's it for this one. It's a shorter lesson. Be sure to like and subscribe. And as always, stay flawless.